Okay, I think I'm going to do the first three in a row here. First, I'm looking for this function, where is this function concave down, which means I need to get to the second derivative. So I start by taking the first derivative, which would be 12x plus 1/2 minus 6 over x squared. Then I can take the second derivative to get 12, and then I'll have plus 12 over x cubed. I need to set that equal to 0. And I can see right away that I have a critical value where x equals 0, because if I plug in x equals 0 into my second derivative, I will have an undefined function. But if I actually then subtract out 12 over x cubed from both sides when I set that second derivative equal to 0, I'll have 12x cubed equals negative 12, divide both sides by 12, and I'll have x cubed is negative 1, x equals negative 1. So I have a number line that is f double prime with the critical values of negative 1 and 0. So if I plug in something like negative 2 into my second derivative, I'm going to get out a positive. If I plug in negative 1/2, I'm going to get out a negative. And if I plug in 1, I'm going to get out a positive. So I end up having a concave down interval where the second derivative is negative, which is c, between negative 1 and 0. Second problem also has to do with the second derivative because it's looking for an inflection point. And they're saying that there's an inflection point at x equals negative 1, and they want the value for k. So if we have first f prime will be 4x minus k over x squared, and then f double prime will equal 4 plus 2k over x cubed. And then they're saying, okay, f double prime of negative 1 gives us an inflection point. So if I plug in negative 1 into my second derivative, I will get out 0. So that means that 4 minus 2k equals 0. K must be 2, and my answer is C. And I'm going to stop with just those right now.